Welcome back. In this video, we look at how we can transform text data to numeric data for machine learning. We've made vectors out of text before when we computed cosine similarity. In this notebook, we take another look, this time with a different toy corpus, about Mary and her little lamb. sklearn has two approaches for extracting numeric features from text. One is CountVectorizer, which uses counts or frequencies, and the other is TfidfVectorizer. First, we'll look at the CountVectorizer. We need to import it, then we need to create a Vectorizer object. Once we create that object, we can apply the fit function on a corpus. What the Vectorizer will do is tokenize the text, then assign a unique integer ID to each word in the corpus, and then count frequencies for each word. When we created our CountVectorizer object, we didn't specify any parameters, so it just used the default values. And that's what it outputs here. Full documentation is available at this link, and you can see there are quite a few options here that we can use to highly customize this. I'll explain just a few of these. Analyzer is word, meaning we want to look at word tokens, not characters. Binary is false, meaning that we want counts, not 1, 0, present, absent features. N-gram range here is 1 to 1, meaning we just want unigrams. We did lowercase the text. Max features we didn't specify, but you can specify you only want a certain number of words. That's important when you have a huge corpus and you want to limit the vocabulary size to just the important words. So this code right here is just giving us a peek inside what it learned. Normally we don't need to do this, but it's kind of interesting when we're learning about these functions to see what they're really doing. First of all, recall our corpus. We can consider these to be 5 tiny little documents. And we can extract counts, convert them to an array, and then print that out here. So what we see is a very sparse matrix. Most of the cells are filled with 0. Each row represents one document, and each column represents one vocabulary word. And we can print out what those vocabulary words are. So this column is bring, day, followed, had, is, lamb. See that lamb occurred most documents. We can also extract the vocabulary as a dictionary. The code for the TfidfVectorizer will be very similar, and again there is excellent documentation in sklearn. We import this particular vectorizer, create an instance of it, again using just the default settings, and then fit it to our corpus. We can take a look at a few things just to see what it learned. Again, we have the same vocabulary, and we have some IDF values. The fit method learns the vocabulary and the IDF, which we printed out here. The fit transform method learns the vocabulary and the IDF, and then returns a document term matrix. It's essentially the fit method followed by the transform method, but if you do it all in one method like this, it's more efficient. This output is a little strange. What it's telling us in this tuple here is the document, and for each word it's ID and the TF-IDF. This is a little strange to look at. So we can take our TF-IDF to an array. And so here's our sparse matrix, and instead of counts, we have TF-IDF values. Now that we know how CountVectorizer or TfidfVectorizer actually work, let's look at how we would use this to prepare our data for machine learning. And that's shown in this code block here. What we don't want to do is fit transform on all of the data. We want to isolate our test data. We don't want any information to leak from the training data over to the test data, because that will kind of tarnish our results. In this line, I'm reading a sample data frame, and it's a spam data set where we have the text of the messages, and then we have our label, whether or not it's spam. And I'm using the built-in train test split from sklearn. We'll get more into that when we do machine learning. I'm creating the vectorizer. I'm doing the fit transform only on the training data, and then applying that transformation to the test data. And in this way, we make sure that no information from the training data leaks to the test data. One more thing I want to show is that we can add more features. For example, here I'm saying I want unigrams and bigrams. A token will have to appear in at least 2 documents, and a feature can't be in more than half the documents. And what we see is we get more compact information, still in TfidF form, this time representing both unigrams and bigrams. So when should you use CountVectorizer versus TfidfVectorizer? For a small corpus, it really won't make much difference. But as you get a larger corpus, and consequently a vocabulary size increases, TfidF will give better results. And whether or not to just stick with unigrams or bigrams will be application dependent. Sometimes you want to capture things that only ngrams can capture, and sometimes you just want to look at the words themselves.